In this section, we're going to consider what atmospheric pressure is. Okay, so if you think about what it is kind of stating the obvious, I guess. It's the pressure that the atmosphere is exerting on us. Okay, so if you imagined a 1 meter squared cross-sectional area at sea level, then imagine the whole mass of the atmosphere above you, so stretching all the way up, all through the different layers of the atmosphere, right to the edge of space. All that is pushing down on you. So you've got the weight of that over that 1 meter squared cross-section area. So that's what's all forcing down. So that weight on average is 101,325 newtons. So therefore, when you divide that by the area, we get an atmospheric pressure of 101,325 newtons per meter squared. So that is the pressure that the atmosphere is exerting on you at the ground level. So this will obviously change with different levels in the atmosphere, the atmospheric pressure. So you need to be a little bit conscious about where you're stating your atmospheric pressure is. But for most purposes, you can take it as this value. Then, depending on the level of accuracy that you're working to, you can state it to different degrees. So this is obviously in its most exact form, but you might be working in kilonewtons or even higher. So this is written as 1 times 10 to the minus 5. So that's bar. If you remember our previous definition of a bar is 100,000 newtons per meter squared. So all 1 times 10 to the minus 5. So give or take, I mean, obviously there's a little bit of difference in it. Atmospheric pressure is around about 1 bar. So just need to state the difference now between absolute and gauge pressure. So the absolute pressure is the pressure that's, well, kind of the total pressure that's there. So it's the pressure in the volume exerted by any hydrostatic pressure plus the atmospheric pressure. So the difference is that gauge pressure is the difference between the absolute pressure and atmospheric pressure. So the gauge pressure is what we normally kind of measure when we use our instruments. But if you want the absolute pressure, you need to add the atmospheric pressure onto it. Okay, so if the atmospheric pressure, the pressure in your cylinder or whatever it is, your device is at atmospheric pressure, then you have 0 gauge pressure. So just to reiterate, the absolute pressure is equal to the gauge pressure plus the atmospheric pressure. And you should assume in this course, unless otherwise told, that I'm using absolute pressure. Okay. So I mentioned, atmospheric pressure is the whole weight of the atmosphere, pushing down upon us. And so it's quite hard to measure that, really, as you might expect. So you can't just get a tape measure and measure the height of the column of air that's above you. That's completely impractical. So we measure atmospheric pressure another way. We use a barometer. Okay, and there's a schematic of one here. So in this dish we've got mercury, and there's a tube which has been inverted and put into there, and a vacuum has been drawn in the bottom of the tube. Now, because a vacuum has been drawn in here, there's no pressure, and you have atmospheric pressure acting on the surface of this mercury. Therefore, it's pushed it up the tube. So therefore, the pressure in this horizontal plane is the same. If it's reached equilibrium, it's not moving. So the hydrostatic pressure here of this height is the same as the atmospheric pressure. Okay, so the pressure, just let me say that again. So the pressure acting down on here is got to be balanced by the atmospheric pressure pushing from outside. So this is our data in the plane. So here rho g h, and hb is the height of mercury in a cylinder, is equal to the atmospheric pressure. And this is often referred to as the barometric pressure. So you remember in this instance you have to use the correct density, so it's the density of mercury. Mercury is very dense and has a density of 13,600 kilograms per meter cubed.